Hi and welcome. I'm trying to learn electroengineering. Today, generators. And after we've done that, we're gonna do ECU tendon training. The ECU tendon is here, the extensor carpal ulnaris tendon. And if you participate in the ECU tendon training, that's at your own risk. The voltage is only induced when there is movement of a magnet or coil. So it's part 2 of a generator we're doing here already. A voltage is only induced when there is movement of a magnet or coil. So if the thing is just standing around, nothing happens. So that is the reason why we have to make the turbine turning. So turn the thing in the generator. The generator just standing there alone does not do voltage. I'm going to call voltage electricity, as long as we don't know more. Voltage. If it's just standing around, nothing happens. Only for movement. Okay, and inducing, I looked a bit closer up, it means to bring it about, to make it happen. In this context, to make that voltage to happen. And inducing seems to have a pretty fixed or a different use even from using the word otherwise. It's used in the same sense, to bring about, to make something happen, to bring an influence on something, to persuade something to happen, to bring something about, but it seems to be a specific term in physics, so that we're going to encounter that word a lot of times, way more often than it is usually used, but it seems to be, to me, just to bring in physics an electromagnetic field or a voltage about. It just means to make that happen, to bring it into existence. A voltage is only induced when there is movement of magnet or coil. It's a bit unusual to use the word the whole time, but it seems to be just a name for it. The direction of voltage is reversed when the movement is reversed and when the poles of a magnet are changed. Let's read it again. But I have a suspicion that it doesn't get more clear. The direction of a voltage. So voltage can have a direction. If I would understand a bit more about it, I could make a joke. But I don't understand. The direction of a voltage is reversed when the movement is reversed, or when the poles of a magnet are changed. It makes sense that how the reaction happens, the reversing happens. When the movement of a magnet changes, so it doesn't turn in that direction, it turns in that direction. Now the voltage is changing. Or just the direction. But how could voltage have a direction? Or when the poles of a magnet are changed. So a magnet has a north and a south pole. We're seeing that here with north and south. N and S. And I don't really understand it, but it has something to do with the one and the one direction, whatever it means or whatever, how it happens. Magnets, some are pulling together, and if you turn them around, you can't get them together. So some magnets, if you have them with the backside or something, they are pulling to each other, and now if you turn them around, you can't get them really together. And they are repelling each other. And the direction of the voltage is changed if that magnet which turns in it has now the north and south pole differently. Or if that magnet is turning the other way around. Another way to increase the voltage is to place an iron core instead of the electromagnet coil. Inside the electromagnet coil. That's very interesting. That means we're having a generator standing. And when one time someone said, hey, let's make that coil or whatever it is, or the steel, maybe iron, a bit better. And we're putting inside of it just iron. And then the whole thing generates more electricity. So here we're having just this coil. Now someone had the brilliant idea to put just some iron or what it was into it. And that's all, and now the whole thing produces more electricity. Someone else another brilliant idea? Another way to increase the voltage is to place an iron core inside the electromagnet coil. No, I think we understood everything as far as we are now able to understand it. I would like to make a presentation about it, but we don't understand it sufficiently to make a presentation about it, to explain to other people what generators are. We're having the basic things understood. Now we're going to go on, and when we understand more, and when we go back, and we will then try to explain generators. Then let's use a little time to read these two parts to generators again. Now first, where we're having a little generator. There is coal burning, and the burning coal heats the water inside of these pipes to steam. That steam is now pushing against this turbine, and that makes the turbine turning. And because the turbine is turning, that generator is also turning. And inside of this generator, there is a magnet, and that is not turned. And because that magnet turns along all these coiled wires with an iron core inside of them, that produces a voltage. And after putting that through a transformer, we're having burning lamps. The voltage is induced across a coil of wire by moving a magnet into or out of a coil. So it is on the wire, there's the voltage. Moving the coil instead of the magnet would have the same effect. It makes sense. The magnet, whether that or whether one calls, it doesn't make a difference. There is an electromagnetic field which has somehow a changing force because we're moving it. It makes sense. This effect is used in dynamos and in generators. There are three ways to increase the voltage. To use stronger magnets. Makes sense, to use a stronger magnet. Use more turns of wire in the coil. Or move the magnet faster. Or, here, putting an iron core inside of the wire. This process is called electromagnetic induction. There is something with electron happening. There's a magnet turning, and there is this electromagnetic induced because it's turning. If it would just stand there, nothing would happen. A generator in a power station uses an electromagnet to produce a magnetic field. The electromagnet rotates inside coils of wire so that the coils are in a changing magnetic field and the voltage is induced. The magnetic field is there, and that magnet is pulling things on the north pole. It is pulling the wire to it. I'm just going to explain it away. And at the south pole, it is pulling the wire. It's pressing the wire away. Now there's a force happening between this magnet and the coil. But now the magnet is turned. And now that part is just loose, and that part is pulled, and that part is pressed away, and that part is pulled. And now we're turning that thing again, and we're turning it very fast. All the time, there's all the time force happening. Now, and however it now happens, but that this force has somehow electricity in it, there's at least a force, and this force is also invisible and ununderstandable. So why shouldn't it be electricity, also more or less invisible and ununderstandable, as least as far as we are right now? If I got Patreon and the page again. A voltage is induced when there is movement. A voltage is only induced when there is movement of a magnet or of a coil. The direction of a voltage is reversed when the movement is reversed when the poles of the magnet are changing. I don't understand how voltage can have a direction. Another way to increase the voltage. It would be funny if there are lamps who absorb light. I know there are things who can absorb light. I think blackouts can do. And very, very dark things. I don't know. And another way to increase the voltage is to place an iron core inside the electromagnet coil. Okay, that was it so far to the generators. You can, if you're here just for electro engineering, you can go directly to the next part where we will continue with electromagnetic engineering. We will do now the ECU 10 training. If you participate in the ECU 10 training, that's our risk. We're starting with a floodgate. Hands next to us, and we're bringing them down. And again down. Go to still stand all this. And again down. And last time down. And now we counterfeit money check. Hands to fist form next to us and bring them up. And down. And again up. And down. So, we're having 3 joules. I want to explain them in a moment. I'm using a tennis racket. For the exercises, the tennis racket is light or only around 300 grams, but it has a long lever. So whatever dumbbell you use, do it in a concept of 3 joules. The 3 joules are stop immediately as soon as there's pain. Go only as far as you can go with a little bit of effort, and don't overdo it. We just want to strengthen, not to exhaust. Short arm out, and hold the short arm off with the elbow, and bring it slowly to the outside. and over to the other side. And back over. And again over. And the last time over. Over to the other side. And into the middle. And directly onto the next exercise. Long arm out. And bring the rigger to the side, whatever you use. And to the inside. Back to the other side. And again over. And over. That's the last time. And now with the other hand. First smaller, the mannequin neck. Out to the other side. And over to the other side. And again over. Last time. And in the middle. And now with the long arm out, take the upper arm again to the other side. Over to the inside. And the last time over. And into the middle. Now take the dumbbell or racket from the top and lift up. Go slowly over. Back into the middle. It's down. And forward. With the palm of the hand pressing upwards. Up with the arm. Over. And again over. And down. And now with the other hand. Hand from the top. Over. Slowly. Back over. And down. And now palm facing upwards. Over. Again in. And down. Last two exercises. You can use a t-shirt, a sock, whatever. Press onto it with good force and then lift the wrist together. And bring the wrist down. And again. And the last time down. And on the other side, press onto it and bring the wrist up. And down. And down. And the last time. And the last exercise, just press with good force onto it. and with the other hand. And that was the ECU type training. I thank you very much, and until next time.